Alright, hello classes. I am not there today, not feeling the best, but wanted to do a couple of videos for you. So this is day 3 of your Bellwork, and it says to factor. So as we recall, we always do look for greatest common factor first, and then after we do that, then the only other type of factoring we know how to do is if we have 4 terms to factor by grouping. Okay, so let's take a look at our first problem, and it says 5xy to the third minus 10x squared y squared. So in looking at these two terms, I want to choose the smallest coefficient, which is going to be 5, and I want to write the factors of 5, which are 1 and 5. I want to choose the largest factor of 5 that will divide evenly into both of these coefficients. So as I check 5, yes, I could take 5 divided by 5, and I can also take 10 divided by 5. So 5 is going to be the greatest common factor of the numbers. And then as I look at the variables, I see an x and an x squared. I want to take as many x's I can that is common to both. Well, this one only has 1 and this one has 2, so I can only take 1 from both terms. So that's an x to the first. And I have y to the third and y squared. I want to take as many as I can equally from both, so I can only take 2 because the second term only has 2. So this is y to the second and y to the second here. So this is my greatest common factor. But they're not asking for the greatest common factor. They want us to go on and factor. So that greatest common factor becomes my first factor when I am factoring the binomial that I have. So as I look at this, and I have factored out the 5xy squared, what I have left is 5 divided by 5, which is 1. X to the first divided by x to the first is going to simplify out to be a 1. And y to the third divided by y to the second, I had 3 y's multiplied, and I am taking away 2, so I have a y to the first left. Okay, then I have minus 10 divided by 5, that gives me 2. X squared divided by x to the first, I have 2 x's, I am taking 1 away, so I have 1x to the first left. And y to the second divided by y to the second, that simplifies out, and when you divide, you end up with 1. And so times 1 would give you the same thing. So this is the factorization for my original term. For problem number 2, again, we always want to check for greatest common factor first, looking at your smallest coefficient. So I have a 2, a 6, this would be a 1 and a 3. Well, 1 would be the smallest of all those, and the only factors of 1 are 1, and dividing by 1 is not going to be helpful. So then I check my variables, x's, but the last term has no x, so I can't have any greatest common factor. So GCF for this one, there is none. I do have 4 terms, so I will factor by grouping. So as I look at the first set of 2x squared plus 6x, find your smallest coefficient, which is 2. Its factors are 1 and 2. And yes, 6 is divisible by 2 evenly, and 2 is also. And I have an x squared and an x. This has 1, that is the smaller amount, but it's the most that I can take from both terms evenly and equally. So this is your greatest common factor, and you will factor that out in front. And after you factor that out, what you have left, 2 divided by 2 is 1. X to the second divided by x to the first. You have 2 x's, you take 1 away, leaves you with an x to the first, plus 6 divided by 2 is 3, and x to the first divided by x to the first simplifies out to be 1. Now, looking at this next one, I can already see that I'm looking for an x plus 3. I have the x plus 3. That's what I want. So I need to have something out in front so I can factor both of those. Well, the only way that's going to happen is if I put a plus, and then the only thing that they can have in common is to divide by 1. So that 1 is going to become the greatest common factor of this last grouping, because no other number, no variable, nothing else will work, right? So as I factor out the 1 and bring that 1 out in front, the only thing you have left, x divided by 1, is x, plus 3 divided by 1 is 3. And here is where you're doing the happy dance. This is now your greatest common factor of those two terms. So we bring that greatest common factor out in front and say x plus 3 out in front. And what you have left is the 2x plus 1 right here, which gives you your final answer. Quantity x plus 3 times quantity 2x plus 1. And lastly, we have what looks to be another 4-term polynomial, which is redundant. It is a second degree polynomial. And as you look at this, yes, we could simplify this, but if it is given to you as 4 terms, then we want to keep it as the 4 terms. So check for greatest common factor first. So I've got 1, 3, 2, and 1. 1 is the smallest, and yes, 1 is divisible for all of them, but that is not large enough to factor out. And as I look, I don't have x's with all the terms, so I have no greatest common factor other than 1, which is not going to factor out and make a difference at this point. So I group these together, putting together the first two, and again, I would change this minus, because if I want to include the minus, it's going to look like we're multiplying. So I would change it to adding the opposite. So we can see, yes, we are adding these two together in between. And then group together that negative 2x minus 1. So looking at my first terms, I've got a 6 and a 3. Looking at the smaller, which is 3. 3, it does divide evenly into both. And I have an x squared and an x. The smaller Exponent would be x to the first, so I can take 1x out. This is my greatest common factor here, so I put that first. And when I divide, 6 divided by 3 is 2. X squared divided by x, I have 1x left, plus 3x divided by 3x. 3 simplify out to give 1, times x divided by x, that simplifies out, also to give 1, so it's 2x plus 1. Here I have in front of my binomial a negative. And remember, you want to factor out any negative first. Okay, so as I'm looking at negative 2x minus 1, negative 2 and this minus 1, the only thing they have in common is 1, but I know I have to make that a negative because my first term is negative. So I'm going to factor out a negative 1 and a negative 1 from here. And variable-wise, I only have 1x. So this becomes, factoring this out as my greatest common factor, a minus 1. And when I factor out the minus 1, what do I have left? Negative 2 divided by negative 1 is a positive 2 with an x that is still there. So I write down the x. And negative 1 divided by negative 1 gives me positive 1. And again, you want to make sure that your second set of factors are exactly the same. They become your greatest common factor and come out in front with a set of parentheses around them. And what you have left in the second parentheses is the 3x minus 1. This is the factorization of that 4-term polynomial.